Welcome back, dear learners. I hope you all are fine. As you know, our previous lecture was about the measures of variability. We have gone through two measures of variability in the previous lecture, that was range and the quartile deviation. These two measures are not concerned with all the items of the distribution or the data. Today's lecture is concerned with the average deviation and the standard deviation. The average deviation and the standard deviation are dealing with each and every item of the distribution. Let's go through them one by one. Average deviation. Average deviation is also known as the mean deviation. It is the average of the absolute deviations of all the individual scores from its mean value. First of all, there are some steps to calculate the average deviations. First step is to calculate the mean of the particular distribution, or then we have to compute the deviation from of all the values from that particular mean, and after calculating the deviations we have to write them in the absolute form so that we can ignore the negative signs of the deviations, and then we average all these deviations. That is the average deviation. Let us see how to calculate the average deviation in the ungrouped data. As all of you know, ungrouped data is the raw data, and I have already told you what is ungrouped and grouped data. I will not go in detail here. So here the average deviation will be equal to summation of all the deviations divided by number of observations. This is summation of absolute deviations. Why absolute? So that we have to negate the negative sign. Let us take an example. Here I have the data of 5 candidates, and first step is to calculate the mean of this data. How to calculate the mean of the ungrouped data? I have already told you about that in lump sum. Here I will say it is the summation of all the observations and divided by number of observations. Here the observation is 3 plus 4 plus 5 plus 6 plus 7, so it is 25 divided by number is 5, and the mean of this distribution came out to be 5. Then in second step we have to calculate the deviations of each score from mean. That means 3 minus 5, 4 minus 5, 5 minus 5, 6 minus 5, and 7 minus 5. Here I have calculated the deviation of each score from the mean. There are some scores which are greater than mean, and there are some scores which are lesser than mean. There may be some scores or may not be some scores which are equal to mean. Okay, those obviously, those scores which are greater than mean, their deviation will be positive, and those scores which are lesser than mean, their deviation will come out to be negative. To ignore this negative sign, we write these deviations in the absolute form. Only we write the value irrespective of the signs, positive or negative. Okay, here 2, 1, 0, 1, and 2, and then for the formula we have to sum these deviations. By summing these deviations, it comes out to be 6. Then here the summation of deviations, absolute deviation is 6 and n is 5, so average deviation of this data will be equal to 6 divided by 5, that will be 1.2. This is how we calculate the average deviation of an ungrouped data. Now, how to calculate the average deviation of the grouped data? What is grouped data? Simply the frequency distribution is the grouped data. There is the formula for it. It is summation of frequency multiplied by deviation and its absolute value. Summation of absolute value of frequency multiplied by deviation divided by number of observations. Here in frequency distribution, number of observations is equal to summation of the frequencies. Let us take an example. Here I have the frequency distribution table. Here n is equal to 30. First of all, for computing the average deviation, we have to find the mean so that we can find the deviations of each score. To find the mean, How to find the mean of the grouped data? If you have not gone through the previous video, I'm giving the link in the description box of this video. Go through that video and see how to calculate the mean of the grouped and ungrouped data also. To find the mean of this data, I have to find the midpoint of each class interval. How to find the midpoint of each class interval? It is summation of two limits of the class interval divided by 2. It is 22, 27, 32, 37, and 42. Then for mean, we should have summation of fx, that means frequency multiplied by midpoint. Here I will calculate summation of fx, sorry, some fx first. 4 into 22, 3 into 27, 6 into 32, 9 into 37, and I have to sum this column for the mean, so it comes out to be 1030. Mean is equal to summation of fx divided by n. Here a summation of fx is 1030 divide, and we have to divide that by number is 30. So here the mean comes out to be 34.33. Now we have to find the deviation of each score from this mean. What is score here? Here our score is the midpoint of each class interval. We have to find the deviation of each midpoint from the mean. So to find this, we have to write the midpoint minus mean. 22 minus 34.33, and same is case with all the midpoints. Okay, here also you can see some of the this deviations are negative and some are in positive. Then for the formula, we have to calculate the uh, frequency multiplied by this deviation. Okay, here this is 4 multiplied by minus 12.33. It is only single minus, so it is minus multiplied by plus is minus. If it would be minus into minus, then it will come here the plus. Because it's single times minus, so it is also minus here. So to ignore these negative signs, we write fx dash into absolute terms. Only the values are written here, ignoring the negative signs. Then we sum up this column for to find the average deviation. It comes out to be 170.68. So the average deviation will be equal to summation of fx, absolute value of fx dash divided by n, that is 170.68 divided by 30, and here the average deviation is 5.68. Here I will tell you that if you go through the previous lectures, we find mean by two methods. One is the direct method and another is the assumed mean method. I have used the direct method here. You can recalculate the average deviation of this data by applying the assumed mean method. uh, okay, understood. Then after that we have one more measures of variability, that is standard deviation. Standard deviation is only measure of variability which we use for further calculations. It is regarded as the most stable value of the measures of variability. The This concept of standard deviation was given by the Pearson in 1893, and this is also concerned with every individual score of the data set. It is also known as root mean square deviations from the mean, and always the standard deviation comes out to be positive, because when we square the deviations, and negative signs obviously will become the positive signs. First of all, the standard deviation for ungrouped data. This is the symbol for the standard deviation. It is known as the pronounced as sigma. Okay, sigma will be equal to summation of deviation squares, individual square minus mean square, divided by n. It is under root of deviation, summation of deviation squares divided by number of individuals. Let's take an example here. This is the raw score. You see it in the table form. I have written it in table form only for our convenience. To we have to do further calculations in the table. That is why I have written it in my otherwise it is the ungrouped data. Here I have five observations: 1, 2, 3, 4, and 5. I have five observations. And how to find the mean of these observations? It is summation of fx divided by n. Here the summation of these observations is 70 and n is equal to 5. So 70 divided by 5, mean comes out to be 14. Now we have to find the deviations from the mean. That means 10 minus 14, 12 minus 14, 14 minus 14, 16 minus 14, and 18 minus 14. You can see some deviations are in negative form and some deviations are in positive form. Then we have to square these deviations. That means minus 4 into minus 4 which will be equal to minus into minus will be equal to plus, and 4 multiplied by 4 will be equal to 16. And same is here, minus 2 into minus 2 which will be equal to plus 4, 0 to 4 and 16. Then we have to sum up this column, that is equal to 48. Here the summation of deviation square is 48 and number is 5, so the standard deviation is equal to under root of 48 divided by 5, which is equal to 3.09. The standard deviation of this ungrouped data is equal to 3.09. This is how we calculate the standard deviation in the ungrouped data. Then standard deviation in the grouped data. There are two formulas to calculate the standard deviation in the grouped data. One is sigma is equal to under root of summation of f into d square divided by n, and another is sigma is equal to I under root of summation of f into d square divided by n minus summation of fd divided by n whole square. Here f is frequency, d is deviation from mean, n is total number of frequencies, and I is the size of the class interval. Let us take an example and solve it with first formula. For our first formula, we have to find the deviations from the mean, so we have to calculate the mean. And already told you that there are two formulas to calculate the mean. I will go with the direct formula. So I have calculated here first the midpoints, and then frequency multiplied by midpoints, and then summed up this column. This came out to be this, and the mean for this grouped data is 34.33, and we have to find the deviation of each midpoint from this. So I have found the deviation of will be equal to x minus mean, that is midpoint minus mean, and for each class interval it is like this, and some of the deviations here are negative and some are positive. So to ignore the negative signs, we square the deviations. Minus 12.33 into minus 12.33, minus into minus will be plus, and 12.33 into 12.33 is 152.02. And same is the case of with all these. But for formula we need multiplication of frequencies and the deviation square. So here it is 4 multiplied by 152.02, 3 multiplied by 53.72, 6 multiplied by 5.42, 9 multiplied by 7.12, and 8 multiplied by 58.82. And then we have to sum this column. So we have all the things for formula. Here it is summation of fd square, and here it is n. So giving these values in the formula, the standard deviation of this data comes out to be 6.67. okay, I have solved this data with the direct mean formula. You can solve it with assumed mean formula also. Now let us take another example and calculate the standard deviation with another formula. Here this is the frequency distribution table. To calculate the mean, I have to find I have to find out the midpoint irrespective of which method I employ, either assumed mean or direct method. Here I will apply the assumed mean method. You know, you can take any class, midpoint of any class interval as assumed mean, but for the convenience, we take the central class midpoint as assumed mean. So here I will take this class because it's the central class, okay? Then we have to find the deviations from this assumed mean. As I have already told you how to find the deviations from this assumed mean, either you will find by this formula, that is midpoint minus assumed mean divided by size of the class interval, that will be for first midpoint 22 minus 32 divided by 5, this, and for the rest it is like this. But there is another method to write the deviations from assumed mean. Here the assumed mean is this, and the deviation from this and the assumed mean is 0, okay? And then we see the class interval is in increasing order. So the class intervals which are above the assumed mean will have negative deviations, and class intervals which are below the assumed mean will have positive deviations. If this class interval would have been in the decreasing order, that means the highest would be above on above and the lowest would be on the below. Then the class interval below the assumed mean would have negative deviations, and class interval above would have positive deviations. But here we have the class intervals in increasing order, so negative deviations will be upper side of the assumed mean, and positive will be lower side of the assumed mean. Then for formula we have to calculate the assumed deviation square. Then it is 2 multiplied by 2, that is 4, minus multiplied by minus will be plus, and here minus 1 multiplied by minus 1 is 1, and 1 multiplied by 1, 2 multiplied by 2 is 4, okay? Then for this formula, look at this formula, we have to find the multiplication of f into deviation square. So the multiplication of f into deviation square, here it is 2 multiplied by 4, 8 multiplied by 1, 6 multiplied by 0, 2 multiplied by 1, and 2 multiplied by 4. And then we have to add up this column, which comes out to be 26. Next we have to find frequency multiplied by deviation, not square deviation, only deviation. This column multiplied by this column. So here it will be 2 multiplied by minus 2, that will come out to be minus 2, 8 multiplied by minus 1, that will be minus 1, 0 multiplied by 6, that will be 0, 2 multiplied by 1, that will be 2, and 2 multiplied by 2, that will be 4. But here you should keep in mind to add up the negative scores and positive score separately, okay? It is minus 4 plus minus 8, that means minus 4 minus 8, that will be equal to minus 12, and 2 plus 4 will be equal to 6. And we have then to add this, because here the negative value is greater, so the summation of fd comes out to be negative, that is minus 6. Now here we have this size of class interval. As you know how to find the size of class interval, it is difference between two lower limits or difference between two upper limits. Here the size of the class interval is 5, and summation of fd square is 26, and number of observations is 20, and summation of fd is minus 6. Putting these values in this formula, so we get 5. The standard deviation will be equal to 5 multiplied by under root of 26 divided by 20 minus minus 6 divided by 20 square, okay? Then it will be equal, the standard deviation will be equal to 5 multiplied by 1.7, that will be equal to 5.85. Here this data will be will have standard deviation value 5.85. I have used the assumed mean method here to find out the mean, but you can use the direct method also to find out the mean. Do it yourself, it's your homework. Now till now, this is your homework that you have to find the average deviations and the standard deviations of these two data sets, and you can apply the formula of both. Two formulas are there in standard deviation and with both the means. Okay, average deviation, that there is also the assumed mean and direct mean formula. Okay, find out this. This is your homework. Now, till now, we have completed the measures of central tendency, and measures of variability is also complete today. There, in examinations, entrance examinations or competitive examinations, some questions are being asked from these measures of variability and measures of central tendency. Like some question is asked like this: if 2 is added to each value in a set of the data, what will happen to the value of the mean? Does the mean remain same, or it will decrease by 2, or it will increase by 2, or it will either decrease or increase? We cannot say what will happen to the mean. To solve this, let us check what will happen. Suppose I have a data set, this 1, 2, 3, 4, and 5. I have to find the mean of this data set. As it is ungrouped data, it is sum of all observations divided number of observations, and it will be equal to 15 divided by 5. Mean is equal to 3 of this data set. Then the question says add 2 to each value of the observation. Okay, then the new observations will be 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2, and 5 plus 2, which will be 3, 4, 5, 6, and 7. This is our new observations after adding this to what question has said. Now, to find the mean of these observations, it is as above, and the mean of these observations will come out to be 5. What is difference between these two means? This is the new data and this is the old data. The difference between the second mean and the first mean is 2. This 2 we have added to the single observation. This means the mean, if we have a data set and we add 2 to each observation, the mean, what will happen to the mean? Mean will be increased by 2. Okay, now same question is asked by the in case of the standard deviation. If the 2 is added to each set of the value in the set of data, what will happen to the value of the standard deviation? Does it remain same, increase or decrease, or either increase or decrease? Cannot say. This as you know how to calculate the standard deviation, we have to find the deviation of these scores from the mean and then square those deviations. And I will not elaborate here. I will go through the end of the calculation. Standard deviation of this first data set, that was original data set, will be equal to the summation of d square is here 10 and the number is 5. So the standard deviation here is equal to 1.414. And the new data set, what is the standard deviation? We have to check the deviation is from the mean: 5 minus 2, 3 minus 5, 4 minus 5, 5 minus 5. And here the standard deviation, sum of the square of the standard deviation is 10 also. So it is 10 divided by 5 under root, and it will be equal to of 1.414. What you will realize here is that both standard deviations are same. That means if we add 2 to each observation, the standard deviation remains unchanged. It does not affect the standard deviation. So here the answer is standard deviation will remain unchanged. Now you have to keep in mind that if each score of a set is added or subtracted by a constant, here it was 2, let us suppose x, then mean will be increased or decreased by the same constant. Suppose here you have seen, if we added the 2, what happened to the mean? Mean was also increased by 2. And if we subtract by 2, mean will be decreased by 2. Okay, then if each score of a set is divided or multiplied by any constant, then the mean will be divided or multiplied by same constant. If we divide any set of score, if here it was, if 2 is divided to each observation, then mean would have also been divided by that constant. Or if we multiply each observation by any constant, suppose x, then mean will be also multiplied by the same constant x. And in case of standard deviation, you have seen, if we have added 2 to observations, the uh, standard deviation was unchanged, it was unaltered. So we conclude that if each score of a set is added or subtracted by any constant, the standard deviation will remain same, it will remain unchanged, either if we add or if we subtract. But if we multiple or if we divide each score of the set by any constant, then the standard deviation will be divided and or multiplied by the same constant. Suppose if we divide any suppose if we divide each score by x, and the standard deviation will also be divided by x, and if we multiply each score by x, then the standard deviation will be also multiplied by that x. Keep these points in mind. This will help you to solve the objectives like this. This is all about the standard and this measures of central tendency and the measures of variability. I will be back with a new video lecture soon. Till then, stay safe, stay healthy, stay motivated, stay tuned to the channel. Have a nice day.